All right, ladies and gentlemen, we're going to go ahead and begin. And I'm sure couple more people will come in, but just to kind of get started. So the first question is always an icebreaker. What is your absolute dream job? Ooh, a real estate agent. That's so cool. My friend, she's a real estate agent, and she's one of the people who sold Derek Jeter's house. Like, she's younger than me. I actually taught her brother, and she makes way more money than me. Well, you know what? Quite honestly, everybody, let's just be honest. Everybody makes more money than me, but that's okay. Anyway, real estate agent's always a really cool idea. Oh, cool. It's nice to see your ideas. All right, hold on. Let me move this. We got one more coming in. Hi, Noah. And Noah, I'm posting for you the link to the Nearpod so you can follow along, okay? All right, so let's go ahead and let's get started on what we're going to talk about today. And what we're going to talk about today is, wow, I didn't realize how poorly this this transferred from PowerPoint to Nearpod, but that's okay. So what we've been talking about last week we talked about the theory of the atom and how you have this atom that has a nucleus that's made up of protons and neutrons, and then surrounding the nucleus in these energy levels are the electrons. And I'm skipping over 2.02, but in 2.02, what we talked about in there is we talked about the arrangement of the electrons in those shells and how you have them in these shells holding them in this energy and how they release electromagnetic radiation. So in 2.03, what we're talking about now is we're talking about how we're going to test that. And what we're going to do is we're going to look at how, when you heat up an element and it creates a color, what we can use that for. This is actually a really cool lab that we used to do in chemistry, although sometimes it's kind of hard to still do it today. All right, so let me just remind you, and this is like the main idea of the lab, and this is what you needed to come out from it with it. Okay, so this is what you needed to know. So first of all, in an atom, you have the nucleus, all right? And here's the nucleus right here, made up of protons and neutrons. And then flicking around in these energy levels, and there is energy in each of these levels. We call them principal quantum levels, which you're going to learn about next. This holds the electrons in a certain area. Now, the interesting thing that happens is that when we add energy to it, so here we have energy. So if we heat up an element, what will happen is that like this electron here, it'll move to a higher energy state, to another energy level. And so it will move up to a higher energy level. And then what happens is it stays up there for a little bit, parties, has a nice time, and then it goes back down to its ground state, is what we call it. So we call where it normally is oh, it's right here, ground state. And then when it gets excited, it's called the excited state. So we have energy that energizes the electron in the ground state, makes it move up to its excited state. And then when it comes back down to its ground state, it releases that energy that it absorbed in the form of light. Now, it's not always light. It can be anything. But this is the basic idea behind this lab. And this is what fireworks are. I think this is so cool. Whenever you see fireworks, basically what you're seeing different elements. They're getting heated up. And they're getting heated up, and what's happening is that the electrons in each of the individual atoms is getting heated up, and they're moving up to a different energy level, and then they're coming back down, and it makes the colors that you see in fireworks. I think that's so cool. Fireworks is chemistry, so next time you're around fireworks, you have to like explain that the color is because the electrons get so excited, they move up to other energy levels, but the light doesn't occur until the electron falls back down to its ground state, and then it releases that energy in the form of color. So that's a key thing, and that's one of the major questions on this lab. It's like the first post-lab question is how do the electrons generate that light? And they do it not by getting energy and going up to the excited state, but after they go up to the excited state, when they come back down, they release that energy in the form of light. And that's what you're seeing in this picture right here, in both of these pictures actually, is you see the energy going and exciting the electron. The electron moves up to another energy level, and then when it comes back down, it releases that energy in the form of light. Same thing here. Energy is being added and then released in the form of light. So that's the whole basis of this lab. That's basically what this lab is about. All right, so now what you are going to do is you're going to answer the question. Yay! What happens to the electrons of an element when it is heated and produces different colors of light? Now, just to help you, I am going to post in the chat. I'm going to post the PowerPoint so you can go back and look at it again, although there's no words for this one. But I'm going to post this in the chat for you. So you guys, if you want to look at the PowerPoint as you're answering this question, you can do it. Okay, so go ahead and answer it. And we are listening to 2010 music. This is music from 2010. We're just going a little bit less old school. Go ahead and start answering that question. And if you have any questions or if you're just really confused, just put it in the chat box. I can help you out. I just realized Kayla isn't on here. She had a birthday this past weekend. She was on last week saying she was having a birthday. She said she had a good time.
You're amazing, just the way you are. And when you smile, the whole world stops and stares for a while. 'Cause girl, you're amazing, just the way you are. Yeah.
Give you one more song. I remember this song. They played this song so much.
I was doing just fine before I met you. I drink too much and that's an issue, but I'm okay. Hey, you tell your friends it was nice to meet them, but I hope I never see them again. I know it breaks your heart. Moved to the city in a broke down car and 4 years no calls. Now you're looking pretty in a hotel bar and I can't stop. No, I can't stop. So baby, pull me closer in the backseat of your Rover.
All right. Good. Okay, so a couple of things here that I'm just seeing that I just want to clarify. So when you answer this question, what you need to say is you do need to say that the electrons get excited and move up to another energy level. Okay? That does not create the light though. That would still be wrong if you just answered it that way. That would just not, you wouldn't get the credit for it, because and what you do after that. So the electrons get excited and they move up to another energy level. And then what happens? I forgot I need to put this on focus. Okay. Um, and then what happens is that after the electron goes up to that another energy level, then what happens is the electron eventually, the electron falls back down to its ground state and releases the energy absorbed in the form of light, okay? So that's the whole thing. It's not that they speed up. It's not that, um, it's this whole idea of you have a nucleus, okay? And you have your shells, and the electron gets zapped with energy, woo, 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 woo. And when it gets zapped with energy, that electron moves up to another energy level, but nothing happens. But when the electron moves back down to its ground state, when it comes back down to its ground state, that's when it releases energy, that energy that it was absorbed in the form of light. Okay? So make sure you have that clear, because that's definitely one of the questions on there. Okay? Does anyone have any questions on this? Does this make a little bit more sense? Does anyone need any more clarification? If you could please give me a thumbs up or a thumbs down. I guess we lost Jaden. Good. Okay, cool. No, are you okay? Do you have it? We can talk. Good. Okay, cool. All right. Okay. So now let's talk about the lab. Okay. And when we talk about the lab, basically this lab is in two parts. So because it's in two parts, technically you should have like, two sets of variables and things like that. So in part one, what you're doing is something called the flame test. This is so much fun. When you do the flame test, what you're doing is you're basically taking an element, running it through a flame, and then you see the color that they create. Okay. And what you're going to do is you're going to use that information to determine what the two unknowns are. So what you're changing here is you're changing the elements. And then what you're seeing as a result is the color. And part two, it's the spectrometry part. And then what you're going to do is you're going to be looking at emission spectrums of known elements. So you're going to be taking known elements, looking at their emission spectrums, and then from that, you're going to determine what elements are found in a star. So you're going to compare known emission spectrums to emission spectrums from stars. So what you're changing is the elements that you're going to be looking at, and then what you're measuring as a result is the emission spectrum. Okay, so I'm kind of just like stating like variables here. Okay, so what I want you to do, I want you to see if you can figure out what is the control independent and dependent variable for part one, and what is the control independent and dependent variable for part two. Go.
Bite that tattoo on your shoulder. Pull the sheets right off the corner of the mattress that you stole from your roommate back in Boulder. We ain't ever getting older.
Do the best that you can, ladies and gentlemen. Do the best that you can. Don't forget the PowerPoint is in the chat if you want to look at it.
You look as good as the day I met you. I forget just why I left you. I was insane. Stay and play that Blink 182 song that we beat to death in Tucson. Okay. I know it breaks your heart. Moved to the city and I broke down crying. 4 years no call. Now I'm looking pretty in a hotel bar. And
It's okay if you don't do well on it. We'll go over it. See if you can try. Oh, Noah, good job.
So baby, pull me closer in the backseat of your Rover that I know you can't afford. Bite that tattoo on your shoulder. Pull the sheets right off the corner of the mattress that you stole from your roommate back in Boulder. We ain't never getting older.
We ain't never getting older.
We ain't never getting older. So baby, pull me closer in the backseat of your Rover that I know you can't afford. Bite that tattoo on your shoulder. Pull the sheets right off the corner of that mattress that you stole from your roommate back in Boulder. We ain't never getting older. We ain't never
All right.
getting older.
Okay. All right. So let's go over it. Okay. And this would be a good thing for you to take a note on because this will help you with the lab. So in part one, so first thing we're going to do is we're going to talk about part one. Okay. Part one. And in part one, what we're going to be talking about was what is a control. Okay. So the control is the Bunsen burner. So remember, the control is what stays the same. And in the first one, what you're doing is you're taking a Bunsen burner and something called a flame loop. And you're taking the flame loop and you're putting it in the element, and then you're putting it through the fire and seeing the color that it creates. So the independent, what you're changing is you're changing the element. And then what you're seeing as a result, which is the dependent, which you're measuring as a result, is the color of the flame. Okay? Now in part two, the control is always the materials or the equipment that you're using. That's pretty much what you're going to use throughout. It doesn't change. So in part two, it's the spectrometer, which is a machine. And if you look, when you do the lab, you'll see it. It's like this, like a thing that has, you put the flame in and it basically takes all the colors and makes and breaks it down into like the little colors that make up the big color. That's called a spectrometer. Now, the independent is what you're changing. So what you're changing is the type of flame or the type of element. And then what you're measuring as a result is this, is the spectrum created by the substance. And I'll talk about what the spectrum is, and this, you'll find out what the spectrum is later. So this is the controls and independent and dependent variables for both the first and second parts. All right, any questions? Give me a thumbs up if you're good. Good, good. All right. All righty. What? 5 out of 7. Okay, I did it right, so bump that. All right. Part 1, flame test. Okay. So this is what it looks like, guys. Isn't this cool? Look, this is what, now it doesn't look this cool when we do it in school because like, because we don't have all the cool stuff. So it's still cool, but no, it can look this cool. But anyway, if you see all these different colors, so this is the first part. This is the flame test. And can you see this little loop here that you're putting into it? So like this is lithium, this is sodium, this is potassium, rubidium, cesium, titanium, copper. Copper is pretty. Barium, strontium, calcium. So like this is showing you that when you heat up an element, and these colors are created by the electrons getting excited, going up to the other energy level, and when they come back down, they're making the red, the yellow, the purple, the green, the white. I was gonna say white, but I don't know if there's white. I'm sure there is. Anyway, these are the colors. Woo! All right, so what you're going to do is, this is the chart, okay? And in the chart, what you're going to do is you're going to be given known elements. You're going to be given 6 known elements. And then what you're going to do is you're going to write down the color. Now, I put in fake colors here. The colors you're going to be using is like red, green, yellow, that stuff. So I put in fake colors here because what I wanted you to do is you're going to also get 2 unknowns. And what a lot of students do on this part is they write down unknown in here for the element name, and that is incorrect. It's the unknown. And so what you're trying to do is you're trying to figure out what is the unknown, okay? So who can tell me? I wonder if I made this as my next slide. I can't remember, but let's just do it here and not in a Nearpod thing. So just give it to me in the chat. What do you think is unknown 1 and unknown 2 based off of the data in this chart? Put it in the chat. Text it to me personally, actually, instead of to everyone. Chat it to me personally. So everybody, let me know what you think is unknown 1 and unknown 2 based off of the data in this chart. Good job, Danielle. You got it. Emily, you got 1. Ethan, look at number 2 again. Good, Emily, you got 2. Good, Ethan, good. I'm just waiting on Noah. You got it? You did? Emily. Oh, I see it. Oh, you're right. Sorry, my bad. Okay, good. We're good. All right. So that's the first part. That's part 1. So part 1, you're basically, and that's what you're going to be doing in the virtual lab. You're going to be taking the flame loop, putting it in the Bunsen burner, seeing the color, and then you're going to be recording this data down and then determining what the unknowns are. Okay? So that's part 1. Oh, okay. We're just going to do that one. All right. So the second part is spectrometry. So, and this picture here, I love this picture. Well, 1, it reminds me of Pink Floyd, but 2, this is actually what a spectrometer does. So what a spectrometer does is a spectrometer takes light, this is the light, and it puts it through a prism, and then it divides the light into its colors that make it up. Now this is white light, so white light has all the colors of the rainbow in it. But I have ants. They're like all over my computer right now. All right. Anyway, so that's what you're doing in this experiment. Okay. This is what it looks like in the lab. And so what you're going to be doing is you'll be taking like hydrogen and you'll be sticking it here. And then what will happen is that the light from hydrogen will go through the slit, it'll go through the prism, and then it will make like an emission spectrum on this slide right here. Okay. And this is what it looks like. So this is an emission spectrum. So what they've done is they've taken hydrogen, okay, and they made the color, which it makes a purple color if you noticed, okay, and then it goes through the spectrometer, and the spectrometer divides that purple color into this emission spectrum right here. And then what you have to do is you have to read this for each element. I have to say, I don't think this lab is really hard. It's just tedious. This is a lab that you need like really good focus music and maybe like a lot of Scooby snacks just to help you stay there because you have to record a lot of data. So for this one, what you would do, okay, is let's just start with the first one. So we're going to start by looking at this first line. So this is the emission spectrum for hydrogen. And you see the first line here is violet, okay, and it goes down like that. So what you would write in your chart is you would write violet, right, or purple, whatever you want to say, whatever makes you feel good. And then you got to measure it, which means remember how we measured last time? Yay, we're doing that again. So you got 400, right? So you know it's 400. And then you can see that it's got that 1 there. So we know it's 410. Is it right on the 10? I don't think so. I think it's a little over a little bit. So I'm going to say 412 nanometers. Huh? Huh? 3 significant figures? Your knowns? You got the 4, you got the 1, and then you got your estimated number. Look, we're doing it again. Oh my God, it's so cool. We're doing it again. Woo woo. Okay, so that's how we record the data. We can do another one. So let's do this one right here. Let's do the blue, okay? And if you look at the blue, that looks really like right on it, doesn't it? So for the blue, I would record 400, okay? And then 1, 2, 3, 4, 440, okay, nanometers. All right. Although that gives you like 2 significant figures, not 3, but that's okay. Maybe you have to do that. No, you don't have to do that. Just do 440. All right. So that's what you're going to be doing is you're going to be recording for every single line here. And each of these lines, what they do, each of these lines, it's the colors that basically made up the color that you saw. So like if you remember, if I go back, okay, and look here, you can see hydrogen's purple, okay? So what made the hydrogen purple is like these were the colors that basically created that color, okay? So that's how it works. That's an emission spectrum. So now what I want you to do is I would like for you to take a quiz where you're going to be looking at emission spectrum and interpreting them. And when you interpret them, remember that this little box right here, because they're pictures, click on the box. If you click on the box, it gets bigger so you can see it. Okay? All right. So 3 questions. Go ahead and go. Oh God, not this song. No, not that song either. Not that song. Not that song. That'll work. That's kind of give me something. There you go.
You know I'm bad at communication. It's the hardest thing for me to do, and it's
2010 music isn't that great, guys.
relationships I go through, and I give it all away just so I could say that. But I know that you're gonna be okay anyway. You know there's no rhyme or reason for the way you turned out to be. I didn't go and try to change my mind, not intentionally. I know it's hard to hear me say it, but I can't bear to stay. And I just know that you're gonna be okay anyway. Always keep your heart locked tight. Don't let your mind read that. Oh, but I just couldn't take it. I tried out not to beg it, but I fumbled, and when it came down to the wire, it felt right. It felt right. Oh, but I fumbled, and when it came down to the wire, it felt right. It felt right. Oh, but I fumbled, and when it came down to the wire,
Ethan, good job. Look at you.
make it what you want it to be.
Rock on.
I'm sorry I did what I did, but it came naturally, and I gave it up away just so I could say that. Well, I know that you're gonna be okay anyway. When I try to keep myself together after all the opportunities, I try to stay true to you and I try to do what you wanted from me, and I give it up away just to hear you say that. I know that you're gonna be okay anyway. Always keep your heart locked tight. Don't let your mind read that. Oh, but I just couldn't take it. I tried out not to beg it, but I fumbled, and when
All
I
right,
came
good.
down to the wire, it felt right.
Okay. So let's look at this first one, okay? So this first one was asking me, oh, I forgot, is looking at the emission spectrum, which number is the correct wavelength for violet, okay? So violet this is violet right here. So maybe some of you might have thought this blue color here was violet, but this is the violet color. And if you look at where it is, it's about 410, okay, around there. And so if we look at the thing, so it's around 400 to 410, so I would pick A, okay? So that was that one. Next one. Everyone got this one right. So which color is represented by the wavelength 570 nanometers? You were all correct. You said C. So 570 nanometers is boop, 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 right here. Boop. That's it. Okay, good job. And then the last one was look at the emission. Oh, and everyone got this one right too. So what is the wavelength of the first red line? So the first red line is this one right here. And so you can see you're at 600 here. This is 650. So it's between 650 and 660. And so let's see which answer is close to that. And that would be, yeah, 656 nanometers. So that is the correct answer. Good job. Okay. All right. Oh, what happened? Nearpod crapped out on me. That's good. Thank you. All right, hold on. Give me 1 second here. Yeah, I know. Screen sharing stop. Technical difficulties. Sometimes that happens. Like pretty much all the time that happens. Especially lately. Why is this going like this? Over here. Ugh. Okay, let's bring this over here. Sorry for the delay. Okay, there you go. Let's get that back there. It says here, screen share. This one. Okay, we are back. Back on track. Okay, so now what you're going to do. So you're going to do that for all those elements. There's like 5 or 6 of them, okay? So you're going to read the emission spectra for all of them. So you can tell it's going to be kind of tedious, right? You have to look at each line and measure it. Then what you're going to do is you're going to be given an emission spectrum for a star. I think this is kind of cool just to kind of think about, right? You know, like, so this is a star emission spectrum. So like the star's light's coming through and we're looking at it. And these are the lines that this star makes. And then what you're going to do is you're going to look at your emission spectrums and you're going to compare them to this emission spectrum. And you're going to figure out, okay, what major elements are found in the star? And when you do this, you don't have to do the measurements for all the lines. You only have to do it for the really thick lines. That's all you got to worry about is the thick lines, because the thick lines are showing you the heaviest or the largest amount of elements in the star. Okay? So we're going to practice this now. Yay! This will be easier because you can actually look at the pictures. Okay, so same thing, looking at the emission spectrum, and then you can just click on this, and it shows you the unknown, and then you're going to compare it and see if you can get it. Okay? All right, so go ahead and get started on that. They're kind of fun, aren't they? I think they're fun. It's easy when you just look at them like that. Yours will be a little bit harder. Or I don't know if it will be. It might be about the same. It's just you have to like take pictures of each of the emission spectrum when you do it. Everybody's doing great. Great. All right. Good job. Everyone got it right. Yay! Okay, so if we look at this first one, okay, we're trying to figure out which one it is. So if you look at this one, I mean, they're pretty obvious, right? I mean, you can see the lines and how they are and how they match up with oxygen. So this unknown gas is oxygen, which is exactly what you guys put down there. You put oxygen down, which is correct. Okay. And then the next one, this one I was like, wow, this one's kind of like really Captain Obvious, but hey, it's still just looking at it. So you can see all the different emission spectrums, and it's kind of obvious because Mercury is here, and this one looks just like Mercury, which it is Mercury. So this second one is D, Mercury. And then the third one has a whole bunch of them. And so, you can see it could be something like xenon, but it's not. It is neon. And so in this one, the answer is neon. Okay. Good job. Good job on that, guys. Okay. So I just want to talk with you about a couple things on closing up with this lab. And the first thing is a conclusion, because a lot of kids are getting points off for this. So whenever you do the conclusion, it always asks you based on your data, was your conclusion proven or no? And this one it's saying based on your data, which unknown elements make up this star? So what you're doing in this conclusion is you're really not talking about part one. You're only talking about part two. And you're saying what elements make up your star. What and honestly, you could just say the one major element that makes up the star. That's all you have to put in there. The second bullet, that's all you got to do for the first bullet. Okay. For the second bullet, it says, does your data support or fail to support your hypothesis? When it's asking you that, it's talking about this. Okay. So it's a little tricky, but what it's asking you is what evidence do you have that says that the major element in your star is helium? So what you have to do is go back, look at your data and say, because the emission spectrum of the star had yellow at this nanometers and green at this nanometers and blue at this nanometers, all of those were the same wavelengths. And that's what that is, by the way. Nanometers is wavelengths of light, right? So those wavelengths were the same as helium, and that's how I decided that helium was a major element that made up the compound or made up the star. Okay, so this data is supporting this, not your hypothesis at the beginning. And then how do you think the investigation can be explored further? You are always going to be asked that, and you can come up with whatever you want. Just make it, creative. A lot of people just say like study more stars, which would, that's fine. Now, there's one question that they ask you, the second question that they ask you in the post lab. And the second question they ask you in the post lab is about old stars and how old stars are composed of heavier or more massive elements than younger stars. And so whatever element you pick, what you have to do is you have to look at where it is on the periodic table. And if it's at the top of the periodic table, it's probably a lighter element. And it said like things like neon and mercury and things like that, those are heavier elements. So things like hydrogen or helium, hydrogen and helium, these are lighter elements. So if your star comes up with these elements, it's probably a younger star. And then if your star composition comes up mostly with neon or mercury, mercury is Hg, then it's probably an older, more massive star. And this is just a super cool picture of it, just showing you how stars like go from birth, old age to death, and then where they end up at the end. I can't explain it to you, but I just thought it was cool. I started looking around at stars when I was doing this. I was like, God, so cool. I wish I understood it better, but I don't. Okay. That's it. So now we are at the end. Look at this picture here. This is a picture of the flame test a little bit crazier. Isn't that cool? Like this picture here. It's so pretty looking. It can be really pretty when you put a lot of elements in it, when you like burn the crap out of it. Okay, so that's all I have. If this is basically your chance to please put down questions, comments, or concerns. Please post either something that you learned from this or something that you don't understand, or whatever you think, or if you have no, you didn't really like it, or even if it's something like, I really hate the music, can we stop having music? Like, you can have those kind of comments too. But please just give me a comment, and that's all I have for you today. I'm really glad you came today. Thank you for coming, and I appreciate it. And come back again next week, ladies and gentlemen. I can't wait to see ya. This is a
When I
bad
was
song
young,
there. If the world was ending.
I was distracted and in traffic. I didn't feel it when the earthquake
Awesome.
happened,
Good.
but it really got me
Thank you
thinking.
guys.
Were
You have a
you
great
out
day.
drinking? Were
Thank you
you in
very
the
much.
living room chilling, watching television? It's been a year now. Think I figured out how to let you go and let communication die out. I know, we know you weren't down for forever, and it's fine. I know